All right, welcome. So you've probably gotten pretty good at the basics. You know, your classic select star from. But today, we're going way beyond that. We are cracking open the advanced toolkit, the stuff that takes you from someone who just messes with data to a real database pro who builds smart, tough, and seriously powerful systems. Okay, let's get into it. I want you to think about this for a second. Really, how do you get a database to do more than just, well, store stuff? How do you make it combine information, boil it down to the important bits, guard it, and even act on its own? That's the real magic, and that's exactly what we're going to unlock right now. So here's the game plan. We've got 5 killer tools to add to your developer toolkit. First, we'll see how to merge data that's scattered all over the place. Then, we'll learn to ask really complex, layered questions. After that, we'll figure out how to get the big picture from a sea of data, set up the rules to keep that data safe, and finally, make the database do things automatically. All right, first tool up, set operators. Now imagine this, it's a super common problem, right? You've got a list of, say, first-year students in one table and a list of second-year students in another. How in the world do you get one single combined master list of everyone? The answer is the union operator. It is so simple and yet so powerful. You just write a select statement for your first table, type union, and then write another select for the second table. SQL just grabs the results from both, sticks them together, and here's the really cool part. It automatically gets rid of any duplicates for you. So what you're left with is one clean, unique list. Just like that. But what's really cool is that you can ask different kinds of questions with these operators. Union gives you everybody from both lists. But what if you had a list of old faculty and new faculty, and you wanted to find only the professors who were on both lists? Well, for that, you'd use INTERSECT. It only shows you the rows that appear in both of your queries. It's a fantastic tool for finding where your data overlaps. Okay, on to our next tool. You know, sometimes to get the answer to a big question, you've got to answer a smaller one first. Like, if you want to find the names of all the students in Section A, you first need to figure out, well, which roll numbers are actually in Section A, right? And that's exactly where nested queries shine. So a nested query or a subquery is pretty much what it sounds like. It's just a query inside of another query. It's usually tucked away inside the where clause. You can kind of think of it like one of those Russian nesting dolls, but for SQL commands. And the way it works is pure genius, but it's also super simple. It's a 2-step process. First, the database runs the inside query, the one in the parentheses. It gets a result. Then it takes that result and feeds it to the outside query, which then runs to give you your final answer. Simple as that. Let's look at this classic college example. We've got a database table with student names and phone numbers, all tied to a roll number. Then we have a student table that connects those roll numbers to a section. The mission is to get the contact info for every single student in Section A. And here's where it all comes together. That inner query, select roll no from student where section equals A, runs first. The database finds roll numbers 104 and 102. Then the outer query basically becomes select name, location, phone no from database where roll no in 104, 102. And just like that, it pulls up the details for Ram and Raj. It's like a 2-part dance, all in a single command. All right, tool number 3 in our kit, aggregation. Look, your database might have thousands, maybe even millions of rows of data. But let's be honest. A lot of the time, you don't care about every single little entry. You want the summary. You want the big picture. I mean, seriously, who wants to scroll through endless rows of data? You don't want to see every single sale. You want the total sales. You don't need every student's individual score. You want the class average. And that is precisely what aggregate functions were made for. And these 5 right here are the absolute workhorses of aggregation. You've got count to see how many rows you have, sum to add up values, AVG to get the average, of course, and max and min to find the highest and lowest values. These 5 are your go-to toolkit for boiling down massive amounts of data into numbers that actually mean something. But the real magic happens when you pair these functions with the group by clause. The best way to think about it is like sorting your data into piles before you start counting. Instead of just getting a total count of all your products, Group by Company tells SQL, hey, first make a pile for each company and then count the products in each of those piles. All of a sudden, you're not just getting one boring number, you're getting a powerful, neatly categorized summary of your data. Okay, now for a pretty big shift in thinking. So far, everything we've talked about has been about using data. With our next tool, integrity constraints, we're going to start protecting it. This is really the moment you stop being just a data user and start becoming a data architect, someone who builds systems you can actually trust. So integrity constraints are basically the laws of your database. They're the rules that cannot be broken. There are 6 main types, and they are the absolute foundation for making sure every single piece of data you store is accurate and reliable. And here they are. Not null just means a field can't be left empty. Unique means every value in that column has to be different. A primary key is the special ID for each row. A foreign key is what connects 2 tables. Check makes sure a value is valid, like marks having to be between 0 and 100. And default just gives a column a value if you don't provide one. These are literally the guardrails for your data. Let's zero in on one of the most important ones, the foreign key. This is the glue that holds your whole database together. See, by making the CID in the student table a foreign key that points to the CID in the course table, you make it physically impossible to enroll a student in a course that doesn't exist. It's a simple rule that creates a powerful, unbreakable connection. And here we are at our final and maybe most advanced tool, triggers. This is where we stop bossing the database around with every single command, and instead we teach it how to react all on its own. This is how you make a database truly active and intelligent. I absolutely love this analogy because it just makes the whole idea click instantly. A database trigger is exactly like the trigger on a gun. You set it up, and when a very specific thing happens, like someone pulling that trigger, an action is fired off automatically. No questions asked. So what pulls the trigger inside a database? Well, it's one of 3 things. Somebody tries to insert a new row of data, update an existing one, or delete one. And you get total control over when the action happens, either right before the database finishes the event or right after it's done. And this is what the basic command looks like. You give your trigger a name, you pick the timing, before or after, and you choose the event, insert, update, or delete. Then you just point it at the table you want it to watch. You could, for example, create a trigger that runs after an insert on an exam scores table to automatically calculate and update a student's total marks. The database does the work for you. And that's our toolkit. Think about how far we've come. We went from just asking simple questions with select to combining data, nesting complex logic, summarizing huge tables, enforcing unbreakable rules with constraints, and even automating actions with triggers. You have absolutely leveled up. You're not just a data user anymore. You're starting to think like a data architect. So, I guess there's only one question left. Now that you have these incredibly powerful tools to build smart, reliable, and even self-managing database systems, what are you going to build? Thanks for joining me.